Projectile motion, as presented by Charlie the Wizard and Dr. Glenn Braddock. Hello, I am the Court Wizard. You can call me Charlie. And I'm Dr. Glenn Braddock, PhD. Suppose that you are standing, wanting to find the distance to an enemy wizard's tower, so that you may blow it up. How might you find this distance that we will call range? Well, the ancient art of trigonometry tells us, with this ancient incantation, range equals distance times tan alpha. We can summon the missing variable. To solve this problem, to find the range between us and the rival tower, we will need the help of an apprentice. There's my apprentice right there. So, your apprentice stands a measured distance away. In this example, I will say 3.5 magic carpet lengths. He then measures the angle between you and the rival wizard tower, or the object that you're targeting. In this case, the angle was found to be 81 degrees. Then, you look upon the ancient tomes of trigonometry, and you find tangent. Tangent 81 is equal to 6.31. You multiply 6.31 times 3.5 magic carpet lengths, and you find 22 magic carpet lengths between you and the rival wizard tower. Well, old wizard, you're almost right. First of all, we're going to call this an equation, not an incantation, because that's what it is. This is an equation. Second of all, we're going to be using SI units, which is the meter, not a magic carpet length. Thank you very much. And lastly, it's important to understand how these equations work. We don't want to just recite them as though they're an incantation. Looking at you, wizard. So, let me break this down for you. Range is equal to distance times tan alpha. Tan of alpha is tangent of this angle here. We know from our trigonometry, it's times tangent alpha. We know that tangent alpha down here is really just opposite over adjacent, or range over distance. So if we were to substitute that into our equation, distance would cancel with distance on the bottom, being left with range equals range. Makes sense, doesn't it? All things, a spell flies in a parabolic trajectory. Because of this fact, we can use magic to find features about the trajectory. Before we can do anything, we must determine the starting velocity, the v naught. In using another such ancient incantation, we may summon the number v naught. We must take the square root of range, which we just determined, divided by sine of 2 theta. Theta being the angle between the ground and the line that your object was fired upon. Now, before we move on, it is important to remember, everything must be the same. There's a reason all cannonball shots are the same size. There's a reason all arrows are the same. There's a reason that the archer pulls back to the same spot every time. Very good, that's where I agree with you. It is important that we standardize our shots and always use the same weight. Now that we know v naught, we can use a similar incantation to determine the angle to fire. So, when you have a target and you have determined its range and you know the starting velocity of your projectile, you can use this incantation and the spirits will tell you what angle to fire your spell at. Be it a shallow angle or a tall angle. This ancient incantation is written as sine of 2 theta is equal to range over starting velocity squared. Remember that, young ones. Remember it well. Now that we know V0 and range, we can plug them into this equation, which will give us theta. This is our firing solution. We aim using theta, we'll hit the target every time. Now, enough talk. Let's go to the field. Hold on. Order pizza for apprentice. This isn't supposed to be here. Agreed. Let's get to some physical trials in the field. Alright, the launch area for testing and calibration has been set up. I have my starting position, where I will launch from every time for consistency. My spotter position, I measured 3.5 meters away from the starting launch position. I have a reference angle with 90, 0, and 45 marked on it. And I will measure or estimate the angles needed. Got my water balloons. And over there, the target has been laid out. First thing to do, hush. So the first step will be to measure the angle standing on the spotter position between the launch position, which is that X, and the target, which is that clamp. And it looks to be 81 degrees. Range equals distance times tan alpha. And that spits us out 22 meters range. The next step, in order to determine the starting velocity, the V0 of our projectile, is to make a uniform projectile. All of these water balloons have been overfilled. They're nice and big. We are at 180 grams. We need 30 more grams out. Alright, 149, pretty good for an estimate. And fire. Alright, so crunched the numbers and it came out to be about 10.9 meters per second. So now I can plug that in, and given a new range, it will give me an angle to fire at. So we'll pick a new target at a different range. Alright, I'll now determine the range for the new target, which is right there. And then I will get an angle and we'll fire away, shooting from there to there. Calculations said that our angle should be about 5 degrees above 0. So we'll see how that works out.
Another direct hit.
Hi, I'm Isaac. If you enjoyed that video and wanted to see more videos by me, subscribe by clicking right here. You can't hear me. This is just B-roll for the background. Subscribe right here. Like, share, favorite, ring the bell, do all the YouTube things, but you can't hear me because this is B-roll. Look at that subscribe button. Looks so real I could touch it.